Hello everyone. Today we will try and discuss on a case study on redesign of forklift of hydraulic cylinders using the DFMA software. Okay, so forklifts are generally used for lifting some goods. This is how it looks like. Okay, so this is a company called Raymond, which is in US, and they have used a software and then tried to work on the redesign of this particular forklift. Now let us go look what is there, how they have done this. Right. Okay. This is how the forklift will look like. A person can stand on this while moving, and there is a main cylinders are there, and then 10 cylinders are there. Okay, and then this can go up and down. Okay, so this has been possible by using the Boothroyd and the Dewhurst DFMA software. The software basically looks like this. There's a screenshot of the software. Okay, it asks certain questions like what is the item, details on the item, okay, and what is the weight of the item. Okay, so you have to you have here the places where you can enter the envelope and the height, etc. Then an item function is there, whether is it a fastener or is it to connect any other item, etc. Like that. It also asked about each part it will is going to ask about the symmetry. Now first of all you will have to load all the parts here, and for each part you may have to answer these questions here. Now what are the handling requirements? What is there any handling difficulties that are there, like nestling, sticking together, etc. This has to be done for every component that has been added into the assembly here. And the operation characteristics, whether you for tightening, do you have to use a power tool or you have to use a manual screwdriver or a ratchet or a wrench or a spanner, whatever it is. Like whether is there any difficulty in insertion, whether it is self-locking or does it the holes required to be aligned. Is there anything like site of mating location is restricted, you are not able to see the part because of the it is a restriction and of the site, and then accessibility is not there. Now all these questions are asked, and then at the bottom they're giving the total process time. As you keep filling here, the process time also will get increased based on the difficulty level, etc. Plus it also automatically it will calculate the process cost, assembly tool fixture cost, and then the assembly cost, and ultimately it will give you the total cost of this particular product assembly. Now, so this DFMA software is a tool that gives us or aids us to understand the assembly process, and also tries to tell us clearly as to where there are chances where where the cost goes for and where the time happens for assembling and of multiple parts there. Okay, so here again there's another example here. For other questions are being asked, the older one. Okay, the same. This is the previous screen of the same software, but then now it has been improvised and then it is brought to this level. Okay, right. Now, this is the forklift. There are two main lift cylinders are there. This is what they wanted to bring down the cost on. Main mast is there, and then there is the outer telescopic piston, and there's the inner telescopic pistons are there here, and then these are the free lift cylinders and the fork carriage. The fork carriage is there. The entire thing moves up and down. Okay, and this has been operated through power, and so there is a battery, and then the whole thing can be moved up and down. Okay, and an operator can stand here. Okay, right. The main lift cylinders elevate the outer telescopic mast, which in turn elevates the inner telescopic mast via lift chains connected to both inner and the outer mast. The free lift cylinders provide the elevation to the fork carriage. The purpose of this free lift cylinder is to provide the lift to the fork carriage without extending the elevating section and maintain the overall collapsed height. Okay, when nothing is being lifted, the whole thing is called as overall collapsed height, and that they want to reduce it as less as possible. Okay, now there are multiple components here. The first step was to examine the current staging cylinder design and brainstorm the ideas. We discussed in the class that most of these things, but the multiple people, the stakeholders of multi-division has to be there, and then they have to, each one puts up an idea, and then it has to be counteracted, interacted, and consensus have to come again on whether what is the purpose of the part, whether it can be manufactured in a different way, all those things. So they may brainstorm ideas as to how to reduce the part count of the patented cylinder without losing any cushioning or having any increase in the noise or during the staging. A part count and resulting cost reduction was required for this particular one. That is the purpose of this. Okay, the main value of the DFMA software came to realize, and then they started. They found that they had a taste of what this can do, and further they went on. They went on and then tried to make new designs or traditional two-part design and reduced to one part. Okay, so a trial and error kind of how the software's implementation inside the company is being tried out generally, usually with a pilot testing, and or they try to benchmark their requirements there. A combination of our end cap and manifold eliminated the welding and the existing manifold to the tubing side. Now this removed the machining from the tubing and reduced the welding times considerably. Okay, so the top end of the cap was also changed and went about by snap ring and to become a screw on this. This also reduced the machining and on the tubing. Okay, so the lowering the chain anchor also allowed the manufacturing to weld the anchor in a different order in the assembly process. Okay, that reduced the whole thing. Now the hydraulic cylinder assemblies were analyzed with the DFMA software, and they have come to a conclusion here at the end of the day. They brought out the number of parts from 37 parts, which was the existing one, to the 28 parts. There was a reduction of around 9 parts. Then estimated labor came down again from 964 seconds to 734 seconds, and then they calculated the DFA index, which is basically it will be 100 when there is no assembly, and then as the more the complications, the less the DFA indexes. Okay. In summary, using the DFMA software, it allowed these people like Raymond engineers to identify the highest potential part count reduction early in the redesign process. The overall manufacturing design engineering group was able to reduce the manufacturing cost of the model. This particular model, 7,400, reach 4 truck main and free lift cylinders to offset material and transportation cost increases. The free staging cylinders benefited the most by part count reduction. So there are many things there. Sometimes there could be a place where you need not be able to reduce the part count, etc. But wherever it is, there you will find some assemblies are potential places where the cost can bring down, maybe brought down. So the existing design parts was brought down by 37 parts to the 28 parts. Okay, and the other benefits that resulted throughout the course of this cost reduction exercise was the inventories for each main and the free lift cylinders was brought down. The free lift cylinder part numbers went from 8 to 6. The hydraulic lines had to be altered just because we have to accommodate something. You may have to go back and rework on the existing design just to accommodate the small changes that is required for bringing down the cost. Okay, so that is definitely a development charges will be there, but then on the long run all these things will be absorbed. This product improvement project was tremendous success for the MDU group and the Raymond Corporation, and resulted in competence in the same quality, functionality and reliability. Okay, so this is so today we looked at how the DFMA was used, what are the various questions that the software asks, and we looked at the redesign of forklift hydraulic cylinder when they use the DFMA software. Okay, thank you very much. I'll meet you on some other case study. Thank you.